Can you hear us, remote folks?
Yes, now we can.
Yes, excellent. Okay.
I'll just share it.
I'm sharing it, but I can grant you permission so you can actually run this thing yourself. So this is awesome. So you have slide control now. So you just have to move right, left, number, anything good. Yeah. Yeah. Thank you. Thanks. Yeah. Is your mic on?
Now it is?
Yeah.
All right. Sorry for confusions.
Okay. Hey, Michael, just give us a minute. So thanks everybody for joining. So this is kind of an informal meeting. So feel free to like chime in at any point. We're just trying to look for discussion, and really the goal is to figure out like what are the next set of topics we want to work on, and to figure the next interim, like what kind of things we want to do. So like we have an exciting set of people to talk to us today. So just be respectful and kind and ask anything. Thanks.
Okay. I have been trying to find a way to combine my own research, which normally is about performance, with energy saving. And at some point it occurred to me that maybe there is something here in terms of the hardware that is being rolled out and is unnecessary. There is a big question on whether we can do anything about that, how we would measure the impact of doing anything here. So it's, it's all a bit nebulous to me. I have given this talk once or twice in different contexts. I'm just going very quick through the basic motivation and the basic idea. And this is really about, seeing what people think, if there is something that we can really do here. So what is happening is that across the world, we get better hardware, faster links, as people want more speed somehow, faster internet. That would be in wired and in wireless. And my point with this talk is that many of these speed upgrades that we get are meaningless. One example is the 5G antenna that's opposite of my home in Oslo, in the middle of a city, and serves my phone, right? Which where I don't see any benefit at all. Nobody I know would see any benefit. There are, of course, other reasons to deploy 5G. There are many other things in there. Slicing can give you hardware reuse, but I'm talking about the actual capacity upgrade that may often be meaningless. I see two major reasons for too much capacity being rolled out. One is simply over-provisioning. Over-provisioning was what, from my perspective, killed quality of service. It was at least one of the things that killed it in the 1990s as a major model. It was simpler and cheaper to roll out more capacity. It also helps resilience. Maybe even today, most likely even today, is probably the cheapest way to make a network resilient, by just rolling out more links and not fiddling too much with traffic engineering. The question is if this is a sustainable way ahead. Should it be cheaper to enable things like quality of service, traffic engineering, be more intelligent with how we shift the traffic around instead of deploying more hardware? Could there be ways to make these things cheaper, reducing the risk, the cost for manpower somehow, reduce the risk somehow? I don't know that, but I'm wondering, from a point of view of sustainability, I'm not sure if this is the right way to go. We've been going like that for decades, right? But yeah, and then the other thing is congestion control and application demands. I already mentioned 5G on the cell phone as opposed to fixed wireless access or things like that, which may have an absolute justification. But for instance, on a cell phone, it's very hard to notice a difference between 4G and 5G for any practical application. I do see a difference if I decide to offline download a movie, right? Which I never do over cellular, and that's not a fantastic use case. I think for most applications it seems pointless. Most transfers end in slow start. That is already a quite well-known fact. These are just a couple of data points from different papers. One that where we carried out measurements looking at retransmissions. So, you would normally assume a retransmission happens after slow start. Of course, you could have things like high start getting in the way, but generally in our data set, in other data sets, we're talking 80, 85, maybe 90% of connections finishing in slow start, which means that they never even, potentially, they don't even get anywhere close to the capacity that is available. And we're just having many of these flows, coming and going, and it's like, like a big, fat, empty road. If we look at other traffic, streaming video, this is a plot of Netflix from a couple of years ago from a paper. The main point I think I want to stress here is that the x-axis is in seconds. So you see that there are these bursts arriving, but from, in the line below, between the bursts, there can easily be something in the order of 8 to 10 seconds of absolutely no traffic at all on the wire. Which is not so much different from a short flow that begins and ends. Also considering the bandwidth limits, briefly before that talk, actually, just maybe a month ago or something, I looked at the blog of Netflix to understand the rates in the ladder that they're having, and it says that the fixed ladder for 4K, which is the top quality they serve, is at max at 16 megabit per second. So 10 users watching 4K video in parallel over one home link, that would mean, right, you have a big screen, nobody wants to talk to each other, everybody's watching something different. I must have a party where, I don't know, it becomes hard to imagine, right? I set up many monitors in my home somewhere and everybody's in a different room, everybody's watching, 10 people all in parallel, and still that's only 160 megabit per second. So, which is not much at all today, right? 5G has been designed for peak rates up to 20 gig. Wi-Fi 7, we can, in theory, go up to 40. Wi-Fi 6, only 9.6. So, I mean, the numbers are just off the scale, right, with regards to what we're using. And if we do look at interactive traffic, this is all normally delay-based congestion control. It's designed to avoid exceeding the capacity limit. So, the question is, will future applications exceed today's limits, and when will that happen? There's also the question if you just get higher speed from upgrading capacity. I did a simple test here where from my home, I connected to 3 different websites, Google, YouTube, New York Times, which all have a short round trip time from my office, and change the capacity on the ingress. This is using a token bucket, so it's not exactly 100% realistic in how it's limiting, but the general trend will be the same. And what you see is that the median page load time in the plots below, of course, it goes down as you change from 500 kilobit to 1 megabit to 10 megabit, where you see a significant difference. But what you also see is that it flattens. Above a certain value, the difference becomes pretty small. And if we do just a very basic Excel sheet calculation, right, saying what happens if I send 10 packets, or what happens if I send 10,000 packets over a link with 8 milliseconds, and you change the capacity, and you consider the serialization delay as opposed to also the end-to-end delay that you just have from the link, then it just flattens. I mean, it's something that is unavoidable. At some point, you have 8 milliseconds plus basically nothing, and you increase from that to 8 milliseconds plus even less of basically nothing, right? So becomes just a round trip time. Therefore, capacity upgrades really have a limited speed benefit. The benefit would be there if the lengths of connections would scale at the same value, at the same speed at which the capacity would also scale, and if we were not also limited by round trip times in transport protocols. So again, factor of X requires a data use growth of factor X at least, right? Also, the protocols would have to go along. The benefit is really today in practice from upgrading that you get the same delay as before, but you can send more data. So if you don't send more data, then there's not much gain really. total mobile traffic is growing exponentially. People go around claiming this, but that may have to do with other things, right? That's related to how often do we use it, what kinds of applications are we using, how many people are using it, all these kinds of things. Not necessarily one application's traffic is growing in size, which it may not do that quickly. So what I claim, and I have more to support this, but this is just a short overview, right? What I claim is that physical capacity is really not the bottleneck anymore, mostly. And capacity upgrades hardly improve latency. Application stores do not demand more capacity, right? You may be dreaming of holograms, as people do for 6G and so forth, but the applications really lag behind. And also, if you just take this into the future and you start thinking, this is why I've been mentioning 7G here on this top slide. If you think beyond 6G, if you say 7G, 8G, 9G, where is this going, right? We're getting higher and higher and higher capacities, and they're going to be emptier and emptier and emptier. It's a strange trend and not necessarily a sustainable one. There are many arguments for why underload exists, for why it's like that. You can read one of these two papers, or both of them if you want. There are many arguments in these papers also for why congestion control will actually become increasingly worse at saturating the capacity. So it's not, you can't just scale the parameters. You cannot simply scale up the initial window forever. That will not work. There's a deeper architectural issue here, but I'm not going into the details. They are in these papers. And that brings me to my questions. Newer equipment, I've been arguing we shouldn't roll out hardware, basically, that gives us higher capacity, but newer equipment is more energy efficient, right? I suppose that lifecycle assessment should dictate upgrading. I don't know if this is how it's done or if it's happening because of the market demanding it and people saying, you need to have a higher capacity. We need 5G now. I don't know to what degree. I mean, there's got to be a sweet spot where it makes sense to upgrade. I don't know if the 10-year cycle of 5G to 6G and so forth, for instance, is that sweet spot. And then there's also a question about wired networks in the same way. And if I'm right, and we really should do fewer hardware updates, then there are questions like, how would we convince the industry? I mean, I'm sure with that talk, I get a lot of love from people working on my massive MIMO and things like that, right? So lower layer folks will not be happy to stop upgrading capacities. I guess the biggest question for me and the reason to really go around and start talking about that is how to convince funders to put money into this. That will be my biggest question. Like focusing on congestion control again and understanding that underload is an actual problem. We should better use available capacities rather than rolling out new ones. And if this is a sustainability benefit, how would one measure this? I'm clueless. And that's already it. These are my questions. That's what I would like to discuss.
Thank you, Michael. Tolis, go ahead.
Well, I mean, one simple data point against it is if you look at a 1 RU slot somewhere in the POP of a service provider or a data center, the amount of energy that you can cool away there and that's being used has been pretty constant, whatever generation of hardware is in there, and they've just been getting faster and faster, right? So I think if we want to do a useful comparison from greenness, it would come down to, I think, something like, okay, give me the total cost of production of new hardware, assuming that in the production was only green energy used, right? I mean, this whole distinction between the bad and the good energy is another complexity, but let's just assume we convert all the energy to good energy, right? So production cost of the hardware and then, the green energy cost over the lifetime of the new versus the old hardware. I think that's the comparison ultimately. And I think you'll see that because, I mean, we may not have the green energy, but all these things are priced in typically, right? So the upgrades are typically afforded. It's just that the energy that we're using is bad energy, right? So otherwise, I think hardware upgrades are typically always afforded by, the money that they're making with it more. Even yeah, of course, the average utilization of these things goes down and the peak utilization goes up. That's what you budget the hardware that you buy for? What's the fastest hardware that I can afford for peak utilization, so to speak? That's the best service I can provide. And so ultimately, I think it's a lot, more important to try to get more energy proportionality with the throughput in the newer network hardware, especially something which we already have in most of the server hardware, which is 90% of a data center, right? So as a software guy, I always love, having things go software, have more agility and everything, but from the overall energy consumption side, I think it's a much more complicated calculation.
Thanks, Tolos. And I think if you look at it purely as a capacity play, right? So you talked about 5G getting like more peak bandwidth and everything. It's not always, right? Like, so part of the story is that like 5G has like better spectral efficiency than 4G. So you get like more bits per hertz in there, right? And a lot of the time, what is getting used for is to put more people on the same thing. So it's not that somebody is using 20 gig per second, but you're trying to put like way more people. So if you take an example of India, right, this is operator which didn't exist 10 years ago, right? Like, who's like common has like probably 300 million or 400 million customers, right? So they are really trying to squeeze like more people into the same thing. So what like the capacity increase is just funding like or making it commercially feasible to have more number of users for the same amount of spectrum, because the governments have realized that spectrum is something they can sell for a lot of money for all their like budgeting things, right? So I think that is probably another angle you need to look at it. So like a lot of the upgrades, even though some people think it's flippant, right? Like to kind of increase this thing, it's not for one user. It's really for like more users, like to get connected onto the internet. So I just wanted you to think of that angle of looking at things too. Thanks.
And Suresh just stole what I wanted to say. And it's kind of very interesting, like, especially when we say that, especially in your slide, when you said like 5G, do you feel the difference? Actually, in some places of the world, we really do see a difference. And that's, yeah. Yeah. So, and in fact, like, even there is a data to back, like, it's only 15% of the population that still uses 5G, but amount of data they're downloading, amount of the usage, the quality of user experience that they get is very, very different. Another unique point is that many people are mobile only, that is the only way that they connect to the internet. So especially for those folks, like...
Okay, but my point was not against 5G in general, right? My point was against the particular antenna in my in the middle of a big city, right, in a well-connected city, and antenna on my phone. That's what I mean. So I mean, I'm not speaking about these things in general. And then this is more about the future, right? This is why I have a 7G on the slide, because 6G is already unchangeable, and I believe that many things there make sense. I'm not even talking about 5G, right? You make cells, I mean, you make towers smaller and smaller and smaller. You connect more people, but I mean, there's probably going to be a limit at some point of the point in increasing capacity further and further. That's what I mean. And also, if you think of the use cases, right, up until 4G, they made sense. Sorry, but I mean, you had use cases like video conferencing and things like that really matched the application that's happening, right? For 5G, we were going a little bit sci-fi with with remote operation and things like that. Like you have a surgeon, but the surgeon doesn't own the fiber cable. He wants to be out in the woods and do it. Things like that, right? So these things, I think, appear because you try to justify somehow, what you're doing, but the application isn't really there. And this will probably become worse as we have 6G. And so what I'm beginning to think is maybe for 7G, we could take a break from that, just one generation. That's the way I think about it.
Yeah, I think I was next. Yeah, I'm not going to pile on the same thing that Suresh and others were commenting. Just a sort of one observation on comparing things. I don't feel a difference is not necessarily a fair comparison. What you should have actually done is that, have a world where we didn't upgrade, and how does that compare to the current world? Because we do have, like, as was noted, more users and so on. Like, what would the impact have been? So, I mean, given some of this efficiency upgrades and so on, then that might actually have had a difference. And I think the real issue is not necessarily that we have, stuff sitting idle. The real issue is this energy proportionality, and we have plenty to do there. And that's a thing that the future generations of, link layers and other networking equipment should focus on. And to some extent, it already is. There was some work in 5G for that. I know I've been working on 6G quite a lot, and that is actually one of the top 3 features that are being worked on. So you can get your equipment to sleep more with 6G, and of course that is to a large extent also equipment implementation issue, but some of that is relating to standards, to what extent you can shut down some advertisement channels, and how often do you have to be awake to wait for somebody else to ping you, and so on. So that is pretty important, and the numbers are massive. Like you can have orders of magnitude, or at least an order of magnitude difference if you do the design correctly. A difference in power. Of course, there's also many issues like applications that if you have a situation where, well, some of my colleagues were telling me that that there's areas in the world and types of applications that, some games or some such where they're sort of constantly sending something, and that is bad for making equipment sleep. And could we do something there that's interesting? Yeah, and one more point about you said that we should do something with the software, and I actually fully agree. And it's the point of all of this was not to say that we just need to be on the same path for the different generations, but we actually do have to worry about the software. And I would actually expand that a little bit. You just pointed out to congestion control. I think maybe that's a bit wider. First of all, on the congestion control, maybe that's an issue of better information sharing between networks and endpoints, that if you had that, then you could maybe bypass the slow start faster or some such, and it would actually get better end user experience. But it could also be other stuff. I at least personally feel like at home I have a gigabit interface, but I don't feel like I get the gigabit experience, and I think I attribute that to a large extent client issues or server-side issues. I attribute it to the way that we design some of our communication things and applications, that I can't get the news text on a news article before the advertisements have rendered, and the advertisements come from some other source that is somehow always slower than the other things. So I think there's a lot of things that we could be looking at. Thank you.
If I may answer, I mean, regarding energy proportionality, of course, I agree. But I don't think this is, this is to me an orthogonal thing. I don't think that I didn't speak against that. If we make new equipment and that's better in energy proportionality, of course, that's great. I'm talking about unnecessary upgrades in hardware that just give us more capacity that we may not be using. I'm not saying all upgrades are necessary. I'm not saying, in some place of the world we wouldn't need it. But I believe that there is more and more and more unused capacity. And regarding congestion control, yes, for example, you mentioned a direction of possible ideas. This is more at the meta level, right? I would have many ideas. I think there are many things we could do, but I personally see that, for example, funders don't really care about this at all anymore, because it's a solved problem and it's just working and that's it, because they don't see that underload is an issue. So I'm trying to come from that angle to say that actually I think it's a sustainability problem that networks are empty. That's that.
Thanks, Michael. Ali, go ahead.
Thanks very much for your call. I really appreciate that multiplexing should be effectively used. But as colleagues have already said, things are different in different parts of the world. So we have to look at the context and the use case before deciding. But about necessity, there is also the other dimension. You're looking at the access network that one subscriber is potentially served by multiple providers. That's also like you get a signal from 3-4 operators. There are parallel networks operating at the same time. That's also really a wasteful use of resources. It's huge that one network is underutilized, but there are multiple networks underutilized. So what can we do about that as well? Infrastructure sharing. Then you're focusing on the access network. Typically in access networks, multiplexing rates are not huge, like in fixed and same mobile. But what about the core? A lot of the experience you get in the access depends on the core side as well. How are things there? And also you mentioned the life cycle assessment, but I think what decides more on the upgrade, don't upgrade question is total cost of ownership exercise, TCO. Our colleague Esther is doing PhD on that. She mentioned in one of the EIMPACT. So we have to look at it, but the life cycle assessment also comes in there, because you have to think upstream manufacturing and then downstream usage and couple that all together. So that's also a important thing. And I will also emphasize the subscriber numbers. What's changing things worldwide is increasing number of subscribers. In some countries, doesn't increase, in probably in Northern Europe, but elsewhere they increase. So new generation of access networks are used for that exactly. Thanks.
Thanks, Ali. Tony? Oh, Michael, did you want to respond to? Okay. Thanks. Tony?
Tony Lee, Juniper Networks. So I've been selling to carriers for 35 years now, and I have to tell you that there is no such thing as a carrier network that is over-provisioned. Yeah, I can see that's shocking, but it's true. Carriers are economically motivated, number one. They do not buy equipment that they do not need. They do not deploy fiber that they do not need. Okay? Yes, they have to have some resiliency. That is an economic necessity. But they are typically running under capacity much of the time. And there's usually at least one link in their network that is running so hot that it's dropping packets occasionally. This is unhappy for them. So they have to provision to their peak loading, and that typically happens in the middle of the day. When it gets very interesting, of course, is that peak loading is not sustained. We all go to sleep and load falls off. And so if you measure capacity in the middle of the night, yes, there's ample excess capacity then. But again, economics force them to go to peak loading.
Thank you.
Thanks a lot, Michael. And if anybody else has comments, please comment on the mailing list. And Michael, like if you think about like next steps, are you thinking of some kind of like improvements in congestion control to better utilize the links? If you see something is underutilized, is that kind of the direction you're leaning in?
Yeah, I mean, I work on congestion control. I have all kinds of ideas on making it better, yes. But okay. But I'm trying to understand is if this is a sustainability gain at all or not. Yeah.
Yeah, that's good. No,
So
but
thank
I
you.
think like part of like what Tony was saying, right? The peak thing, right? Like, is there a way that in which like, so we can kind of route around the hottest link at some point, so the peak, the upgrade doesn't have to happen that often. It's an interesting topic to think of, right?
So most carriers make extensive use of traffic engineering already to try to distribute the load. And so very typically it's many links are hot at the same time.
Oh, sorry, Tony. I think what you say is absolutely true, but doesn't that more apply to aggregation and core networks as opposed to access?
Yes, that is much more towards access and core, to the core and aggregation. In access networks, what we typically see is a very, very high degree of oversubscription. and we're talking 20 to 1 very commonly. So if you see spare access in a access network, spare capacity there is because there are that many subscribers. They may not be active. Subscribers are very bursty, but there's provisioning there to allow for the number of subscribers that are actually present in that area.
Yep, exactly. Thanks.
So,
Thanks, Jenny. Thanks, Ali.
yeah. So especially on that access side, right, we'd always been thinking on how we can reduce the peak to average, right? Because that's how service providers typically measure that, right? So, and peak is something when, for example, the most amount of TV is being used. And what of course we've been seeing is that, 10 years ago, the short tail, something which could be multicast that everybody was watching, was much more dominant than what it's now. Right, everybody watching their own thing, but they all still watch it at the same point in time because seemingly the work life cycle of humans hasn't changed that much. So there are these peak hours, and service providers built for that. And of course, they'd like to have better peak shaving, but those things start to intrude on user behavior and experience. We've seen that being actively done in other areas like timed pricing for electricity, and then everybody actually starts to, when they can, wash their clothes in the middle of the day when it's so sunny that solar energy, they give you money when you use that solar energy, so to speak. And well, in networking, we haven't done that. We obviously wouldn't even need to be so intrusive. We did have 10, 15 years ago technologies like pre-provisioning content on hard disks. Then the service provider said, no, we can't really measure and control everything, and the hard disk always failed. Now, obviously, these spinning disks are dead, right? So one of the ways of peak shaving for something like the Friday night is, you could start, put another, 1 terabyte disk into every media player and pre-provision during, off times, that larger short tail, like the 100 most popular things on Netflix and others, and then you might be able to get away with a lot less peak capacity in the access, which especially in something like 5G or when we move to more mobile, where I think the energy per bit that we're sending is a lot higher.
Yep.
So bringing back pre-provisioning, right? So we've been talking about that. That's
yeah, we can discuss further, but we have to move on, Tolis. We have to move on. So, yeah, thanks. Good point. Thank you. Romain, you have control of the slides.
Yes, I do. Do you guys hear me okay?
Yeah, you're a bit loud, but otherwise great. Just move back
I'm
a
a
little
bit
bit. I
loud.
think you'll be fine. Yeah, perfect. That's perfect now.
Okay. All right. Good. So it's going to be a good continuation of the discussion we just had. So I'm going to move a bit away from the wireless area and going more into the wired networks domain. And the type of networks I'm going to be talking about are mostly access/metro network. So we typically see quite a lot of under provisioning, as we just discussed. So it's a slide back from a longer presentation I gave. So I'm going to switch quite quickly in the first few slides. So as most of you know, networks consume a lot of energy. This is somewhat comparable to the amount of energy consumed by data center networks. The interesting point I used to make here is that we have increased a little bit in energy in both cases, which is in proportion a lot less increase than the amount of work done by those systems. The issue here is that it's still positive. So we are still consuming more and more energy, even though we are doing a lot more with data centers and telco networks in general. So that's an issue, right? That's an issue because it's very easy to keep increasing the network capacity, as Michael just argued. We tend to do that a lot, but it gets harder and harder to improve energy efficiency. So we need to progress because more energy requires more electricity. Electricity comes from carbon sources still primarily today. Okay, now we all know this. If we do things naively, the networks stay up all the time. That consumes a lot of electricity. That's an issue. I'm going to go a bit quickly there because I think most of you in this room know this. Network devices are always on. Their power profile tends to be kind of flat, so there's very little proportionality, as we talked about. And this happens because networks are underutilized. and we know why this is the case. Now, you may wonder, we just had an argument before that all networks eventually at some point during the day run at high capacity. We're kind of interesting to try to verify this. So to try to get some real data from few ISPs that would be willing to share that information with us. And what we find is, so we got data from two small ISPs in Europe, Switch, which is an ISP in Switzerland, and Surf in the Netherlands. Both are research university networks that provide internet access to university and public institutions. Those are sizable, couple hundred nodes networks, but not saying the largest share of traffic you can imagine for an ISP. Still, in such a network, what we see is that the average link utilization of a link over time is very low, like very low. That may or may not be surprising to you. The actual number was a bit to me. Does that generalize? I don't know. This is just one single data point. The point I wanted to make is that, of course, we want to strive for more proportionality. How can we do that? Well, we can do that by either running at higher utilization, or we can try to do some sleeping options. Okay, we can turn off a certain number of things in a network. I go through those things quickly. To go to today's main point, we try to do a study on putting links to sleep, right? Why links? Because it's the simplest unit or the smallest unit one can consider putting to sleep in a network. So how does that look like? Well, we try to go with the simplest approach possible, right? So nothing too fancy, nothing too complex. We know the theory of how we can do this. We can turn out like in the fashion of what the energy efficient internet was doing this. You can buffer packet and then wait a bit, sleep the link, then you send your burst of packets in one go. That doesn't work today. That doesn't work because we cannot turn up the link fast enough. Like we're orders of magnitude too slow in order to make that realistic. But we can still try to leverage this daily pattern that we have in the data and turn off at 9 time in the low time on the links that are typically unused and wake them up when we need them. If it's a couple times per day, even if it takes 10 seconds to turn up the link, that's still acceptable. So how would you do this? Well, the simplest thing we could come up with is to have a process where we actually monitor the link loads in our network. Then among among the links that are lowly loaded, we can select some that would be fine to put to sleep. I will explain what I mean by that in a second. You turn those to sleep, right? You instruct the power off command. And if you should have an increase of utilization in your system that is somewhat unplanned, either due to a failure or due to whatever sort of flash crowd event, then your controller can wake up your links. You may suffer from sporadic congestion that will be resolved as soon as the link are back up. The only tricky thing in this description is how to select the links you can turn off. And again, we try to go for the simplest way possible. So we took all the links in the network, prioritize the low utilization links. So we rank the links by their current utilization rate. We define a maximal budget of traffic we allow to be rerouted by the process of turning links off. We verify that we don't create local bottlenecks, and we of course verify that we don't break the network connectivity. And if you just follow those simple heuristics, we found that on the two networks we could study, we turn off about 1/3 of the link, right? And this 1/3, if you see the data on the graph that shows the number of links that can be turned off in the entire network, is capped, right? It looked capped. Well, this cap is actually a spanning tree in the network. So one more link would be disconnecting the network. So effectively, what it means is that in every nighttime in the lowest utilization possible of the network, only one path is enough to carry entirety of the traffic. Of course, you may not necessarily want to reduce your network to a spanning tree. We can discuss that later if you're interested. There are more details into the how we do this and some subtleties and so on. We presented this recently. We can talk about this more if you're interested. The key question we had was, okay, we can do this. It actually works. It does not create congestion as far as we can see, but how much can we really save by doing that? It's still kind of tricky to assess this, but one thing we can do is to look at the transceivers that are effectively being deployed in those networks and get power numbers for those, and then multiply the two together and get an estimation of how much we would save. Unsurprisingly, if we turn off about 1/3 of the link, we'll save about 1/3 of the power budget of the transceivers, right? And of course, this is only a fraction of the total power draw of the entire network. How big is the transceiver power relative to the total network power? Unfortunately, as of today, we don't have a way of answering this. It would really depends. If you look on a per device budget, if you have a small switch that doesn't throw much power, then the transceiver power is going to be a very large fraction of the total. If you have a very big core router that have, I don't know, many fans and a lot of processing units, it might not be that much. It's kind of unclear as of today. Second point is that if we turn links off, we will save more than the transceiver power. There will be some power saving also on the router side, so in the internal router components. We know this because we've observed this in the lab, but those are still pretty hard to quantify. So we need more, there's more work to be done to answer those questions, and those are kind of like the ongoing things we work on in my research group. We need better power data. Data sheet, as you may know, gives you typically very little information about the actual power draw of a router or a switch. So we try to shed some lights into that. Thankfully, there's a lot of ongoing discussion within the IETF of what data should be collected and how to collect it and how to make it easier to access this via young models or other approaches. So I'm glad to see that happening. For the time being, the best approach we have to get trustworthy data is to get direct measurement. So external power meter that you plug it into the power supply in it, and then you get the data out. One side benefit of this, then we can get very high time granularity, so we can observe the power effect of traffic bursts and things like that in the reading, which you typically will not get through SNMP data or young data. So ultimately, what we want to do is create a database of all these sorts of information, and yeah, this is something that is currently ongoing. Once we have this data, we will be able to build power models for a router or a switch, which is pretty basic. There is nothing very fancy in there. That's also something we're currently working on. To facilitate this process, we designed essentially measurement units, measurement boxes that we can ship, and you can literally just plug it into your router, and then all the data collection process is automated with minimal setup on your side. That's something we are starting to deploy now with operators that are interesting to contribute to the data collection process. So essentially, you can see it as the equivalent of a RIPE Atlas system, but for power data. Yeah, I talked about this Hypnos protocol or idea today. There are some limitations in the evaluation that we've done because it had to rely on simulation. So far, nobody was willing to try out this in an actual setting. We did our best to estimate where the traffic would go if we were to turn links off. So we have sensible intuition that we do not generate, we do not induce congestion, but we don't yet have proof of that or validation of that. I'm discussing now with people at Orange and people in Swisscom to eventually try that on a share of their network. If you're interested in that as well, please feel free to let me know. I'll wrap up now to leave as much time as possible for discussion. There are a few more slides in the slide pack. They're not critical to present today.
Thank you. Thanks. Tony? Go ahead.
Hi. So I have some answers for you, Romain. I'll present them in the green buff, but you're absolutely correct. Optics are a big contributor. They are number 2 on the list. NPUs are first, and then optics are the second biggest power contributor in a router.
Thanks. Yeah.
Thank you. I was going to talk about the green box stuff as well. So there's like some stuff Tony's going to present, like, from at least like from June, and there's somebody from Cisco also presenting like something, how we measure the things as well. And there's like a little bit more depending on the kind of equipment you're measuring. So if you're looking at like core routers or switches is one thing. There's also something that's closer to the edge on the Wi-Fi side. There's like some slightly different kind of things that are there. And for the operator stuff, maybe talk to the IEPG or actually go to a RIPE meeting. I think you could probably kind of make that pitch directly, because I don't know, like, so personally, my worry is like, are people willing to plug in this black box that they don't know much about into the network, right? I think that's like a concern, and how you would use the results for that. So I think it could be an interesting place probably for the IEPG next time to kind of go pitch that. The IEPG is like a set of operators kind of who meet on IETF Sunday.
Okay.
So
like, is that similar to a RIPE meeting, or?
No, it's more the operators who come to the IETF, right? Like, so there's like a slide, there's like overlap from the RIPE meeting or NANOC meeting or APNIC meeting, but it's like people who kind of are interested in IETF stuff. So that's pretty interesting, yeah. And this the baseline that you kind of base this on, right? Like, how stable is it like over time, right? Because I think these things can stay like stable for a long time. So how do you detect like that baseline is changing and get out of it? I think it'd be interesting for you to explore. Thank you.
Thanks, Suresh. Just as a side note, I did a very similar presentation to the RIPE meeting a year ago, something like that. And some of the data that we use for this study come from contacts I've made at the RIPE meeting. It's definitely an interesting crowd. And some of them are willing to put those boxes in their network, it seems.
Thank you. Tolas?
Yeah, so one of the unfortunate problems is that of large numbers, right? So in a data center, 90% of the energy consumption comes from servers, 10% from the network. So guess how interested the data center operators are to optimize energy consumption of the network, right? If they instead could go for the 90% problem. So let's talk about a wide area network. I don't have exact numbers in the same way because they vary quite widely, but the total energy consumption of the core is similarly negligible to the total energy consumption on the edge. If you go mobile, it's even worse, but even, all the power for all the DSL lines, DSL stuff on the edge, and all these switches for tens of millions of users easily exceeds what's in the core. Yeah. So that also means you need to look at the topologies and the very limited redundancy that you have on the edge, right? So in the US, for a long time, you simply had a ring. So you were connecting, 10 millions, and only one of the links could ever be down, or else you would lose connectivity. Now, if you go to more densely populated areas like the US, or even here, the big cities, you may at best have hub and spoke with dual connectivity. So yeah, you may be able to take one of the links down. But unfortunately, we don't even have the technologies over fiber right now to basically say, oh, what happens if the other link then fails, right? How do we recover, right? In the Anima stuff that we've been doing, we've been saying that, well, if you can have an in-band management channel still running, then we could still bring up, the link that we switched off the data path for. And in actual, non-IP optical equipment, there are these type of channels that are very low powered, but in routers, we typically, and I forgot all these strange abbreviations from ITU and IEEE, they have crazy things at the optical level, which I'm actually quite, would love if we would have them going into routers, but in routers we don't, right? So I mean, if you switch off physically the optics transmitter in a DWDM interface, there is no way that you signal something to the other side. So that's one of the big pain points why I think operators will not be able to easily adopt something like this unless we improve our ways on how we deal with interfaces.
I totally agree.
Thank you. Ali?
Thanks, Romain. Very helpful, I think. One thing I want to add on the data center versus telecom network comparison is about virtualization. I guess level of virtualization, cloudification in data centers is much higher than in telecoms, although it's increasing, and that helps optimize resource use. So that's one thing. And also, as Torle said, the distributed nature of telecoms versus rather centralized as far as one data center is concerned, it's really helping save a lot of resources, energy and else. One thing, the title of your presentation triggered in my head was, I thought also we could look at what's keeping the, let's say, links or nodes up. What are the protocol features, characteristics that are not letting equipment sleep? If we can handle that in a, let's say, systematic way, perhaps we get some benefits as well. Like what are the keep alive things, signaling, as Torlo said, even at the physical layer, there are things we cannot avoid, or perhaps we can. Yeah, thanks.
Thank you. And I just want to butt in for a second because we have somebody here who's Rolf. Rolf is in this room and he was actually studying a bunch of multicast traffic in the IETF network. I don't know if you want to kind of chime in with that at some point on the list, right? Because part of the stuff was he was actually studying how he was actually studying the IETF network and how the IETF protocols use multicast and broadcast and how it kind of affects the energy thing. So I think that'll be really cool, Rolf, if you can send it over at some point, okay?
So we didn't study energy actually. So we did study how much privacy and private information, personal information is being distributed by those protocols. Yeah.
Okay, thank you. Thanks.
I have a question on, initially your assumption was to evaluate the average link utilization on the switch. Wondering if you were considering that switch can have, let's say, multiple links for the same, let's say, reachability destination, and whether we can, thinking beyond the first hop of the switch to say, okay, if we have to look for next hops, then we can maybe concentrate traffic over one link, and then also turn off multiple links that go in the same, to reach different destination.
Yeah, I see what you're saying. So we don't do that at the moment. So we do look at, so there is an easy thing to do is that when you have bundle links, so you have multiple parallel physical lines that connect the same two routers, then you can optimize a bit this. So you can optimize the bundle so that you keep the number of links you need between those two endpoints. But they are local, right? They are direct neighbors. You could envision to do something similar by taking one hop neighbors or, two hop neighbors, depending on how you look at it. We don't do it as of now. In principle, there is nothing that prevents you from doing that. We didn't do that because we were just really trying to find the dumbest thing one could do, right? And so the dumbest thing we found was, let's take all the links and then turn off the least used ones and see what happens. And we were kind of surprised to see that already works quite well. But then one can, of course, optimize, and easy extensions or easy optimization to the system would be, learn from your mistakes and so on, and so that you can proactively turn things back up before you need them. And I think that would be probably more useful than trying to optimize in a way which of the links you turn off. If one would be to optimize this, then I would most likely try to optimize for power. So you would try to turn off the links that draws the most power, and for that has, so essentially that means that are the more power hungry optics.
Thanks, Romain. And now we need to move on. And Dan, You're on.
Okay, I thought I was last, but okay, here we are. Hi. Okay, so do I get slide control now?
You have control, Dan. I gave you
great.
slide control. Yeah.
Perfect. All right. Well, thanks. I want to take it in a slightly different direction, which is the last two talks have both been about this critical aspect of how do we mitigate the impact of the internet on on climate change. You know, it's in UN speak. There's kind of mitigation. How do we reduce the impact? And then also there is adaptation, which is how do we keep it going given the climate change is happening? And that's really the question that I wanted to throw out. And to be honest, this is a result of Yari and Suresh asking, can we think about topics that are out of the box or different or things? Because I don't actually know what the work is, if there is work here for the IETF, IRTF, IAB, but I want to pose the questions and think about this. Right now, we're seeing a lot of change. The kind of proverbial question that gets asked is, you know, with rising sea levels, what happens to all the cable landing stations for the sea level rise? There's also larger storms, erosion that happens. Now, some of this, in this particular case, may be somewhat simple, in one way. And there was when a tsunami hit, I believe it was Japan, when they were coming back and restoring systems after that, they were just going back and moving the cable landing stations 50 meters higher. Those are perhaps some things that could be solved, but it is a question. What happens to those areas? Destruction of infrastructure. Just a little bit south of you right now in Oregon, in the United States, there's large-scale wildfires that are affecting communities and places that are affecting the infrastructure, the pieces that are there. We just saw, as I mentioned here, Hurricane Beryl hit Jamaica. Extreme heat. This past Sunday was the warmest day ever until Monday. So we are seeing that, and that creates immense demands for cooling for, places, homes, buildings, hotel centers, everything that's out there, creating severe electrical demands. We're also seeing drought, water, cooling issues that are coming into place with this. So the question really sort of is, how do we adapt the internet to be more climate resilient? And if you look at some of these different issues, so much of this comes down to energy and electricity, power infrastructure, deployment. Generally, we've just thought about the internet in terms of that the electricity is there for the most part. So how do we think about it differently? Many of the efforts are out there. You see community-centered connectivity, CNs, community networks, internet-based, internet exchange points helping build local resilience. LEOs can provide a role, but if there's a lot of questions, and certainly they don't have the capacity to make up, what happens when a subsea cable goes out or whatever. Caching, CDNs. There's people looking at local first applications. How do you build something that does more locally and then syncs up to servers or to other systems out there? The green BOF with all the energy efficiency. And we also have to think about human resilience. How do we ensure that there are people who are strong technical communities out there that can operate and maintain this? So my question really for discussion was, is there a role for the IETF, IRTF, IAB, or is this something really more for the operator community, for the NANOGs and the various different network operator groups and other groups out there? But is there a role for us in thinking about this adaptation and how do we work with it? Is there protocol work? Is there stuff that could happen there? Is there a new research area within the IRTF? Is there, thinking about this in terms of liaison to the other groups? Ali, who's coming up next, had mentioned to me, and which I was not even aware of, was the ITUT in their study group 5 has a whole question 12, which focuses a lot around this, not entirely, but part of that. So that was really my discussion question is, what's the role? Is there a role? Where else could the IETF, IRTF, IAB play in this? And that's what I got.
Excellent question, Dan. Any comments from the team?
Yeah, Laurent Chavalia. Thanks. Very interesting. From the network management research group perspective, we have also some reflection on, we call it green networking, but I think your point on the resilience and survivability can also be taken into account from a management point of view. I mean, a few years back, we've been looking into so-called autonomous networks, where this, robustness and survivability is also a key characteristic. So I will say from the software part, or let's say more the logical part, if the infrastructure is a bit up again and running, there could be also things to think about how to ensure reachability, or if you have islands of connectivity that comes and goes. So there could be also things to do from, let's say, a management layer point of view that could be at least to have as a discussion or investigate a bit this part of the problem.
Oh, sorry. Hi, Dan. Thanks for bringing this up. What I want to say is that to a large extent, the challenges you described have been experienced somewhere in the world already. Like when we talk about internet in some parts of Africa, or even we saw in the Gaia session how Indian, or as they called it, but Native American reservations are including or building internet and the challenges they are facing. So these challenges are already faced within certain communities. I know is helping them already. So the idea is this is becoming a mainstream topic now. But we can already look for the coping methods of these disadvantaged communities. And this is bringing the inequality side of things. Basically, challenges are already experienced by disadvantaged communities. Now, at large, we are beginning to see it take effect. So we can benefit from the already existing solutions, I would say. Thanks.
Oh, no, it's a great point. And to be clear, there's a lot of research, a lot of papers, a lot of pieces that are already out there on this. So you're absolutely right. You know, people have been looking at this. There was a presentation actually at the ANRW here back in 2018 that looked at some of this, the cable landing things and some of the pieces around that. So there is a lot of work around that. And there's a lot of activity happening in different places. A lot of the activity tends to be on the mitigation side, on how do we reduce the impact of things. But there is a lot of questions around this. And so my question really is, you know, is there? And the answer might be no. You know, there's a lot of other groups already handling this. It's not an area for the IETF or TFIAB. So, and that's fine. I think we just have to ask that question and be conscious about it. And I see a cue.
Oh, sorry. So another aspect, we also deal with climate change adaptation. And what we see is that the problem might be a little bit technical, but it is more on the solution side. Basically, how do we bring different technology enablers, components together to solve a use case in climate change adaptation. So we really have to work on the context and the use case to be able to identify what's there missing in the technology toolbox, I would say. Thanks.
Thank you. Thanks, Dan. And that's really interesting presentation. And I just want to give you like a pointer, right? Like there's like stuff we've done similar to this. It's like if you look at MOPS, it's really a place for video industry people to come and gather and talk about the issues, and not necessarily to do any protocol solutions for that, right? Like so, right. I would think like, you know, the ops area like could certainly like have some kind of discussion kind of group that where people can come and talk about issues and probably just put them down and I'll maybe talk about like how they've handled issues and stuff like that. So it's really about knowledge sharing and doing it. So I'm just throwing that up as an option. Probably go talk to Warren or somebody and see if they're interested in like doing something like that, right? And the other thing is like this is a plug for the IAB open meeting. So we got somebody who built this indigenous community networks in Manitoba to come give us a talk on Thursday if you can attend it. It's like fascinating, right? Like, how the challenges faced and everything. I think it might be good to make that connection to kind of, if you're interested, if you can attend that, to kind of go talk to them and see. And I think like ISOC is somehow plugged in, but not to this specific person. But I know this ISOC has like a community network kind of thing. But I think this could be an interesting thing for you to listen into for the challenges they face. And it's like Canada, a rugged country, like, so they do have like different set of challenges as well, that like, where they go. So yeah, thanks.
Thanks for the pointer. We do have somebody within ISOC who's very focused on Indigenous communities and connectivity. I'll make sure I'll flag it to her to let her know too.
Yeah, thanks.
Yeah, really good stuff, and worth thinking about. I'm not sure we have an answer on whether there's IETF work or not, but of course, all of this, like moving the sea cables or the local networking communities and so on, all of that is important. So I wanted to bring up a couple of things that I don't think were mentioned. One is sort of the supply chain, that if a large storm happens somewhere, where's the part storage or part supply to fix those things. Another thing is that the internet is sort of very dependent on other stuff, and how do we ensure that if that storm happens on some other continent and takes down a bunch of servers or a server farm, then the rest of the internet isn't brought down because we're dependent on that piece. And I think there's work there. Maybe part of that is like how we deploy things, and maybe there's also protocol work. I don't know. A lot of the protocols tend to have options for connecting to multiple different places, but then the deployment fixes that to one particular location. But that's certainly an angle to look at as well.
Yeah, it's a good one. And yeah, the interconnection, right? It's great if you have local caching, local resilience, but if you're using global services for authentication and you're cut off, then your content might be right there, but you can't authenticate to it. So what are you actually getting? So yes, lots of interconnection to think about.
Well, and maybe it's not really about the IETF or IRTF as the organization yet, but as the individuals in it. For example, as part of outreach or working across the aisle in other organizations, right? So, for example, I haven't tracked, but I'm not sure what is happening about green in Nanook, right? So there are quite a few people regularly from the IETF also going to these events, and I think it's not a problem to set up a workshop there about green if something like that hasn't happened. So next one I think is in week before IETF in Europe, in RIPE. So might be an opportunity to reach out to the operator community and get more feedback than what we get with the fewer operators that we have locally here in the IETF. But yeah, I'm not sure how much they've already done, so I'm not frequent in that regularly.
Good suggestion.
Thank you, Ali. Yeah, last chance to chat. Thanks.
Thanks. Then I also work on non-technical aspects of sustainability. And what I see is that we should not isolate technical questions and deal with them in a bubble. Basically, the question of resilience of a community is not distinct from the resilience of the internet in that community, be in a disaster or in a disadvantaged location in the world. So if, for example, the internet itself contributes to the resilience of a community, like we see in the indigenous communities, then it's vice versa. You have people there who can fix that when there is trouble. So they empower each other. We shouldn't forget that. And IETF, IRTF can certainly invest in making the communities more resilient in using the internet. That it is not an imported thing that's installed there and works. And when it breaks due to disaster or climate change, you have no clue how to fix it, for example. So we can play a role in that. Thank you.
100% agreed. And, it's not just the technical side. I mean, obviously here at the IETF, we're talking the technical side, but it's definitely something we just kind of all need to be thinking about. So thank you all for the time, and I look forward to the next talk.
Thanks, Dan. Ali, you have control of the slides.
Thank you. Thank you so much. Good morning once again. This is just going to be a, let's say, listing of topics which I feel could be handled to form a link from our energy-related focus towards the greenhouse gas emission reductions, which is at the end what is going to make the difference for the environment. So if I restate the problem once again, we are working on a multitude of energy efficiency, energy saving optimizations, like we saw from Michael and Romain, and we'll see in the BOF today. And that's great, and that's what we need. And the immediate motivation or impact from that activity will be on cost savings. We know that operators are after cost savings, and that was the trigger a couple of years ago, unfortunately, due to circumstances. And now we are really pushing for energy consumption reductions. But at the same time, while this is necessary, it might not be sufficient to make a difference in climate change mitigation. And what is the path towards that climate change impact from what we are doing in energy? So basically, I identified these topics. I want to go through them and see if you guys feel they are being worked on sufficiently, or we can take them up. Some of them have been mentioned already. So obviously, energy consumption has to come down. And for that to happen, we see a lot of activity. And in the BOF today, we will also discuss the metrics. But also there, we have to think, what are we, let's say, asking these metrics for? Is it for control, or is it for reporting? At what granularity do we need them? What frequency are we going to collect them? So we have to really ensure that we focus on usability of these metrics and support them with use cases. Then, for example, I see papers optimizing the energy efficiency of DNS. Okay, but what is the role of DNS operations in the overall energy consumption of the internet? Is that huge? No, I don't think so. So why do we work on DNS energy savings? We have to ask. I'm not saying we shouldn't, but let's see, where should we invest in energy efficiency, energy savings, proportional to their impact? Energy proportionality, we hear all the time, and I cannot emphasize enough that the importance of that. But we also need to understand the end-to-end impacts of infrastructure shutdowns. Romain was rather confident that it was okay, but I guess we need more examples. And what is critical is that in addition to cost budgets, we should have carbon budgets as well. We put the metrics in, we put the energy saving features, but how much is enough? Or where do we hit the limit? Currently, we don't know. For an access network, for a base station, for aggregation or core, what are the limits we should be confined in? Of course, it doesn't sound good talking about limits, but it is necessary. Then going through the rest, carbon intensity. Basically, how can we increase the use of renewables in our operations? So there is much to be done in collaboration with smart grids. Do we add new APIs so that our carbon-aware routing and traffic steering can use that help? And going fast, I know my time is up, but traffic rebound effect is a huge topic, which we feel is a bit distant from us, but there are certain things we can do to rein in the impact of traffic increase on ourselves, some of which just came up. And also infrastructure expansion. How can we do that in a more responsible way? Infrastructure sharing and also dynamically designing our capacity versus peak load pre-provisioning. So there are lots of backup slides to the set. I just want to hear your feedback. What area matters to you most? Thanks.
Thank you, Ali. Marisol, go ahead. Marisol, we cannot hear you if you're talking. Marisol, can you hear us?
She said audience not.
Okay. Okay, so I'll take you off the queue, let Romain go, and then you can try again.
Okay, thanks. Can you guys still hear me?
Yep.
Okay. Thanks, Ali, for the presentation. I just wanted to bump back on both what I presented and what I think we should primarily work on. I presented this work on turning links off, and there's some argument in the discussion that that might not be saved the most. I actually agree with that. Right? We started looking at this just from an academic curiosity of people saying it's worth it, it's not worth it. And we're kind of like wondering at the end of the day, how much could we save by doing that? Do I think this is the main driver and what we should be working on? No. I think it should be worked on. I don't think it's the most urgent and the most promising avenue. And what I think is most promising as of today is the search for more levers for proportionality in today's network. And I think this will not come from the protocols. This will come from the hardware. This will come from better use of the hardware we have today and better design of tomorrow's hardware. And when I say better design, I mean design with more proportionality in mind. That would be my answer to your question.
Mm-hmm. Thanks. Yep, I appreciate that. Although I think we have some software impact as well for energy proportionality.
Yeah, definitely. I mean, what I presented is like one tiny part of that, right? Mm-hmm. There's something that can be done in software, but I think we won't get 10x improvement with just software, or at least not at protocol layers, but more at the driver layer with finer control of the hardware we have.
Mm-hmm. Yep, thanks.
Thank you. Marisol, you can try now.
I think I can go next.
Yeah.
Sorry for the audio issues. Thank you for the presentation, Ali. I just want to make a note, right? You were considering the energy consumption, getting the right metrics on a scope
Marisol?
Frequency.
Marisol,
Yes.
your audio is coming in too muffled. Can you get slightly closer to your mic?
Okay. Is now better?
It's perfect.
Okay. Yeah, I just want to make a note on the right metrics that Ali was highlighting, and I think it makes sense as well with other comments that we have done in the past on the call. You talk about the scope, granularity, and frequency. The consistency on the metrics is key, because I think this is where IETF can make a difference. You know, as a proponent for the green BOF, I think we can bring some clarity as well from the technical point of view and be able to compare apples to apples. And the other point I want to make here on the energy, and when we talk about carbon, operations people is not part of those conversations in organizations today, right? This is done by advisory, it is done by a third party, that validation. and they are in another world, right? We are not comparing the same metrics when we talk about carbon and the energy consumption, because they go with estimated values that are far from the real. And I think these conversations could come closer if we can try to make an effort as well on the metrics definition.
Yes, yes, absolutely. But I think we need to make an effort to create metrics for carbon as well.
I agree, totally agree. Yes.
Sorry?
I agree with that.
Oh, thanks. Absolutely. Thanks, Marisol. Yeah.
I just wanted to agree with Romain on this energy proportionality being a high priority, but I just wanted to slightly disagree what you, Romain, had said about that being an implementation issue or sort of a hardware issue. Yes, like not 99% or 90%, but there are some areas where standards and sort of set technology also matters, like in radio networks, what frequencies you have to listen and to how often, how you schedule things. That does affect the possibilities of when you can actually go to sleep. So that's important too.
Mm-hmm. Yeah, exactly.
Perfect, thank you. And we are really at the end of this meeting. So thank you everyone for making this early start. It was like an excellent set of presentation and great discussion, and we'll continue on the list. And so we kind of want to have this like once in a while we meet in person, but we really want to meet mostly virtually and off the IETF cycle. So keep the topics coming. Whatever you want to talk about, we'll schedule a meeting when we have a set of topics. And again, go enjoy your any BOF working group you're heading to. So the digital emblems looks really awesome. So
thanks very much.